Alright, now that we have the keys all figured out from that previous video, we can now do some encryption stuff. I'm going to just go through here and then we're going to encrypt and decrypt stuff. We don't need very much for this. I mean, this is just a couple functions to encrypt and decrypt. We need system, or the sys, and pickle. And we'll discuss the pickle here in a second. I'm going to pull one thing out from my math function. It's we want to do the mod power stuff. So we're going to take something to do a real big, we're essentially going to take the message encoded as an integer, raise it to a really big frickin' number, the ETH number, and then we're going to do a mod really big number on that. You do that normally like we did in our demonstration of principles with the percentage sign. The interpreter is just going to freak out and take forever or crash. But you can do some tricks, math, just look them up, to do call it power mod, and it's really fast. And of course that's going to go look for that and fail if it doesn't find it. We're going to have some helper functions here. We're going to be able to one of the things when you encode a system, you're going to need your message to be smaller than PQ or N. So we're going to take N, as we're going to call it number limit here, maybe I call it, and we're going to turn an int, which is a giant integer, maybe it's 1,000,000 digits long, and we're going to chop it up into an array or a list of ints that are smaller than N, or in this case PQ. The reverse of it is taking a list of those ints and putting it back into an int. And hopefully this will make sense. Our encryption is right there. That's all we're really doing. So we're going to take my object that we're passing to it. We're going to give it what I'm going to encrypt with. This is essentially my key. Maybe I should just call it key and deal with it, but I didn't. You're calling it out by variable name. It's easier for me to read. That's really why I did it that way. And an object. Now the cool thing is the object can be text, it can be a data structure, it can be anything. And what we're going to do is we're going to take pickle right there, and we're going to use the dumps, which is going to marshal or serialize this object into a binary. Now from that binary, I'm going to take the int and turn those bytes, because this will do bytes, right? It's basically flattening out the data structure. And I'm going to turn it into an int. So I get an int. So I have a data structure, be it a dictionary or text or whatever, is now represented as an int. So knowing that I can't encrypt something that's bigger than PQ, which it probably is at this point, because it could be like 10 gigabytes of data, which would take forever to encrypt, by the way, and under this mechanism, and I turn it into a list of ints. So then I'm going to encrypt each element in that list, which is guaranteed now to be able to be encryptable because it's less than PQ, or N, as maybe should have called it, but oh well. And what we do there is we just do this guy right there for, we're going to run this guy in Python, standard Python, to run it for basically each element in the int list. I'm going to encrypt it. And all you need to do is do that number to E mod that. And that does it. So I get a list of encrypted ints. I'm using the highest protocol to make sure it's the newest and bestest and awesomeness or whatever. And then I'm going to dump that back as a return. So I return a binary back as the encrypted object. The reverse is, the decrypt is really just the reverse. I'm going to take this guy, the return, and there's my D, right? And I'm going to take my encrypted bytes and load it to my list. So, I'm going to unpickle it, if you will, deserialize it, and that should be this list of ints right there, or well, the encrypted list, which was this guy right there, kind of hard to read. And then for this guy, I'm going to do basically the same thing. I'm going to unencrypt each element in that row, and then put it back into a single int, using that as my number. So remember up here I got the number limit again. So that's going to take that list of ints and put it back into an int. So at the very end of this, I have got an int. for some reason. I think that we need to release memory, trigger garbage collection. Don't know if I really need that. I'm going to take this int, I'm going to turn it into bytes. This is right from the Python description of the int functions, and turn it into bytes, and then I'm going to do the load, and the result is my load. And I return that. Of course, if it doesn't work, you know, if somebody tries to use a wrong key to do it, and you get errors and whatnot. So let's run this thing and just walk on down it. So what are we doing? So notice that we didn't have any keys. So I'm going to, in the main here, I'm going to import my key functions and generate 100-digit and a 200-digit prime and generate keys from that. And I got that. And you know, let's clear the old stuff out because we don't care, and just type keys. And here's my key, and the key's in payload. So I'm going to check to see if I got it. I got it. I'm going to type keys again because I'm lazy. And there's my keys. Okay. And what am I going to do is print the standard out. This is the object I'm going to encrypt. My object. It's a dictionary. You know, txt, test text, hard to say, int, there's an int and a list. Okay, great, we're going to encrypt this object. Encrypt, decrypt, so everything is now done. I guess if I could look there, there's my encrypted one, and the decrypted one should look like the thing that passed it. So I already know it worked. Here I'm printing out my keys. Here I'm printing out the data I'm encrypting. That's what it looks like encrypted. That's what it looks like decrypted. Tells me what type it did. I've just demonstrated it kept the type, which is really cool. And did it work? I'm just saying if it worked itself, and it did. And we can even come over and say, okay, well let's do ourselves. This is a test. Now, completely different data type, right? I don't know. I'm so typematic about this. Could be anything. But okay, so this is a text string right now. I'm gonna hit enter. And it's going to go and it's going to decrypt, encrypt to decrypt. It's going to print, this is what that up here encrypted to, and that's what it decrypted to. Did it work? Yes, true, done. That's our encryption system. We have encrypted and decrypted and decrypted and encrypted. With all that stuff, we generated keys. We're now ready to start putting this into a real life environment where we can start maintaining keys and then encrypting and decrypting things for our scripts.